What I want to point out with this is if we evaluated the 10 to the third, pretty simple and easy, right? We've got 10, 3 zeros, 1,000. What did you get when you did 5 times 5 times 5 times 2 times 2 times 2?
Found 3 factors of 10.
Ooh, some people found 3 factors of 10. I like that. But even if you didn't, you'd be like 25, 125, 250, 500, 1,000. So it is 1,000. That wasn't that easy to do. But if you identify your 3 factors of 10 here, 10, 10, 10, it is 10 cubed, which is 1,000. That's kind of easier. Ooh, I kind of drew a monster right here. Like half clam, half monster.
That works.
Look at this. Give him a big earlobe. But on this side, just a little one. Okay. That was just, I got inspired for a second. Sorry about that.
Give him a beard.
So thinking about that warm-up, what I want you to do with your partner is fill out this table. So you're going to see this is what we just looked at. And what they did is just follow this. You can skip this step right here, actually. But what they're just saying is 5 cubed is 5 times 5 times 5. 2 cubed is 2 times 2 times 2. Because of the commutative and associative properties of multiplication, we can rearrange all this in any order. So they paired up our 5s and 2s to each be a 5 times 2. 10 cubed is much easier to do, okay? So that is a 10 cubed because I have 3 factors of 10. So you're going to try that for the rest of the table. This table, and there's some parts that are trickier than others, right?
Yeah.
Let's see. Benny, what color you want me? You're inspired me right now, Benny. I got it.
Pink.
So,
No, you have to do pink.
is everybody seeing those 2 factors of 3 times 7?
Yeah.
That's 21 squared then.
I didn't write it like that.
So for the next one, I've got 4 factors of 2 times 3. Which is 4 factors of 6. To get to 15, what are the factors at my bases I need to use? 5 and 3. So 5 cubed and 3 cubed. So that's a 5 times 3, 3 times. Which is 3 factors of 15. Now this one's kind of fun because there's several answers. I'm just curious, what base did you use?
6 and stuff.
Some people did 6 times 5. What other ones are out there?
15 times 2.
15 times 2. You could do 1 times 30, but I was thinking maybe like 3 times 10. Let's do. I'm going to do 6 and 5 so I have fewer digits to write. That's how I was thinking about it. So 6 to the 4th times 5 to the 4th. That's 1, 2, 3, 4 factors of 30. Okay. Now this one's a little tricky. I've got 2x, 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 2x. But to get it right, your 2x has to be in parentheses. Because if you write just 2x to the 4th, no parentheses, the 4 is only going to apply to the x. And both things need to be to the 4th power. Does that make sense? If there's no parentheses, it means something different.
Mr. Mac, is it okay if I wrote it a different way?
Yeah. So this one, I guess the only way you could write it expanded would be something like a times b, dot, 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 because we don't know what n is. So I'd rewrite it as ab in parentheses to the n. So it has to be in parentheses, otherwise only b would be to the nth power. Yep, so that's a good mistake. That mistake's the bomb. And down here, I'm not going to expand all these out, but I'm going to have 4 factors of 7 times 2 times 5, which is 70 to the 4th. Now, what did we notice about all the examples in this table and the exponents? What did we notice over here,
The
Ivy?
exponents,
Ivy?
they all meant.
Well, the exponents are the same, and like if you just multiply the bases, I guess you would just get like a base.
All the answers are.
Yeah, well, it's because they're all kind of, I would explain all these as they all got kind of paired up, right? And so what we noticed then is, this would be 21. What do you think is the most common wrong answer if a kid goes by not understanding what the factors are doing? If they go by memorization, what do you think the most common wrong answer to this is? 21 to the what power?
4th power.
4th. 4 factors of, there's not 4 factors of 21 here, right?
That'd be a lot of
Well, like, no, you guys are all going to be like, yeah, duh. I'm going to tell you, if you go, some people that do the memorization thing, they're going to write it. If you just take a brief moment and think, What does this mean expanded? It means I have 4 factors of these and 4 factors of these, which means I have 4 factors of 2 times 3. That takes you to what to do. Otherwise, you're going to be like, sometimes I add the exponents, sometimes I keep them the same, sometimes I multiply them, sometimes I subtract them. That's a lot to like try to keep track of with memory, right? Would you guys agree? So, again, just don't even write it expanded. Think about what happens if I expand this. What's happening to my factors? And the what's happening will take you to the keep it the same, add, subtract, multiply. Like, it'll take you there by concept, okay? Would you guys agree there's a lot to keep upstairs if we're trying to go by memory right now? Yeah, but use the concept to get you there. Partner, I want you and your partner to try to write 2 cubed times 3 to the 4th with a single exponent. So like number to a power. Try it out. So I'm interested in hearing some of our answers. Next color, inspired by Brendan.
Look, I kind of used,
What's an answer we got? Who got an answer
I
for me?
used a calculator to get my
6
answer.
to the 3rd times 3.
We got a 6 to the 3rd times 3 as someone's answer. What else do we have? I mean, that's kind of not just a base to an exponent, but I'm writing it down.
Mine's kind of cheap.
Let's hear a cheat code.
Cheat code. So basically, you can divide 89 by the square root because together they.
Oh, did you multiply everything and then take the square root and say that squared?
Yeah.
So so I like that. You
That's why I
could
was saying
say,
it's a bit cheap.
yeah, well, your square root that you wrote down, it's going to be an irrational number. So those digits keep going. But I like that.
It's a bit
Yeah,
of a
I-
cheaty way.
648 to the 1st power.
Okay.
Oh, yeah.
All right.
6 to the 3rd. Okay.
This isn't. Anybody else have anything different? Why can't? What about this? Anybody get this?
Oh, wait a minute.
Wait, but that won't work.
No, it doesn't work.
Yeah.
That's the whole point. So
Oh, I'm not smart.
the reason that you could kind of simplify it to be like that, kind of. Maybe it doesn't help you, but there's only 3 factors of 2,
81.
and there's 4 factors of 3, right? So we can pair up 2s and 3s there to all be 6s, right?
Oh.
So this isn't even like the right answer. The whole point of this is you can't. Why can't we?
Because the base is the same.
Because we have different number of factors for each, so they can't all pair up.
See,
But we could pair up 3 of them if we wanted to. And this is called numerical flexibility. This means we can see how numbers are decomposed and recomposed. And guys, this is so good for just general math. Breaking down numbers and reassembling them. So I want to show you this. That could kind of achieve, but we can't just go one number to an exponent unless we have a 1. Because we cannot pair up all of our bases. So in order to pair up those bases, multiply the bases, we have to have the same number of exponents. Next, what you're going to try as a group, and I took the easy one. You're going to try to make the number 3,600 in a variety of ways. Okay? So I did 60 squared already. I did 60 to the 5th divided by 60 cubed. And I did 6 squared times 10 squared already.
Wait, what?
So this is just 8-3. There's not a lot of space for you. Okay? It says how to play. We're not playing the points like that. You're just going to try to get as many ways to get 3,600 as possible. Now, here's like an untapped resource in my examples I gave you. Negative exponents. So try to find as many ways as you can at your table or a small group.
isn't that infinite?
It's 8-3. There's infinite answers.
Yeah, that's
Yeah.
what I thought.
But try to get as many as you can. We're going to start assembling some answers. So I'm going to slam down one that I had said. That's 60 to the 4th times 60 to the negative 2. Who's got some more with multiplication that we could do? Just like, let's think of these as 3 columns. So I took 60 to the 4th times 60 to the negative 2. What do you got, Zeph?
For the first equation,
Yeah, for the first column here.
I got 3,600 to the power of 1 times 5 to the power of 0, which is 36.
Yeah, that gets it done. 3,600 times 1. What about, here's a fun one. 60 to the 500th times 60 to the negative 498th. That's kind of fun. All right, Ryan, what you got?
6 to the power of 2.
6 squared
6 to the power of 0.
times 10 squared.
times to the power of 0.
Yeah, but it can't just be this.
Oh, it can't just
Oh, you're saying 60 squared
yeah.
or 6 squared?
60 squared.
60 squared times 10 to the 0? Sure, that works.
I was gonna do
Okay, middle column, using the quotient property. What do you got, Meredith?
60 to the 740th power, divided by 60 to the 730th power.
There we go, that's 60 squared. Let's get one more there. That is the same as anybody else. I heard someone say negative. That's the same thing. This would be the same thing as 60 to the 740th times 60 to the negative 738th. Those would be the same things. That's kind of cool. Who's got another one with the quotient property for me?
quotient division.
No? Yeah, division. All right, Ryan.
All right, 6 to the power of 15 divided
60?
by 60, yes.
Yeah, to the power of 15.
75?
I'm going to guess it's 60 to the 13th.
Yes.
Okay. So really, if it's a quotient, you just need a difference of. Let's do a fun one. I'm gonna get crazy. 60 to the negative 4th over 60 to the negative 6th. Woo! Does that make 60 squared?
Yeah.
Sure does. That's fun. Ivy, you got one?
1800 to the first power times 2 to the first power.
Yeah, that works. That would kind of like be over kind of in this mode. Okay.
That's a lot of the first power ones.
Okay, what else over here? What did I say? 36 times 10 squared? That would get us there. Is there another way? We could do 6 squared times a hundo. Now, I want to show you something else that's kind of fun that I was surprised first hour I hadn't seen before, okay? That is this. Let's get a whiteboard up here. That is this. Sometimes it's really nice to see how a number's made up. And we can do this by breaking it down into prime numbers. Let me show you what I mean. I can divide it by 2, 1800. I'm going to circle that. I can split up as 2 and 900. Split that up as 2 and 450. I can split that up as 2 and 225. I can split that up as 3 and 75. I can split that up as 3 and 25. And split that up as 5 and 5. So what I've done is I've decomposed my whole number into prime numbers. And prime numbers can't be divided by one or only one itself. So check out this kind of cool one I could do. 2 to the 4th times 3 squared times 5 squared. And this is just a good skill to have for a lot of problem solving because, like, if you look at 3600, do you think it's divisible by 48? No, like you don't know, right?
No.
So check this out. 2, 4, 8, 16 times 3 is 48.
So, yes.
It's totally divisible by 48. And then you might be like,
Actually, another way is
what? 48 times what? Well, the answer is 525 times 3 is 75. 48 times 75. So it breaks it down into its most basic factors so you can reconstruct and see how it's built. It's actually really cool. Like, I use this to problem solve a lot. Because if I look at 3600, I do not see 48 times 75. Anybody else? No, but I can look at these little factors and multiply. Any combination of these prime factors are building blocks for this number 3600. And that means all the factors are the combinations of these prime factors. It's pretty cool. Ryan?
another way you could see it is 48 is divisible by 3, and 3600 is also divisible by 3. Therefore, it must be divisible by 48.
If it's divisible by 3 and something else, because there's things that are divisible by 3 that.
That's true.
Yeah, but I like what you're thinking there.
It's like a general thing
Yeah.
you could say.
Yeah, so this is called prime factorization, and you don't even have to do it like I did it by 2s. You could start with 3600 and seriously do like,
Divide by.
you can divide by 10, like 136, and then you just break up those things, 2 and 50, whatever you see, 25 and 2, until you get to prime numbers, and it'll always be the same prime numbers, 6 times 6, 2, 3, 2, 3. You can do it any way you want it. It still gets you the same factors. And again, it's a great way. Do you guys notice I do some fast math with big numbers sometimes and stuff?
Yeah.
It's all based on this idea of breaking bigger, more difficult things apart and reassembling them in an easier way in my mind. This is one thing that really helps with that. And that number fluency, you can use it for the rest of your math career. So just a helpful little thing. Today for homework, You are going to finish your formative. We got a lot of time for this. You're going to finish your formative. You're going to do the cumulative practice in your packet. And if there's still time, you need to do the Khan Academy. I'm giving that I put on the Canvas schedule for today. Now, you have to be using your time well. I'm giving you a lot of time to do this because
How much do we have?
like almost a half hour. But if you're not using it well, what am I inclined to do next time I have time?
Give us less.
More or less, right?